All right, so today we are talking about covalent bonding. Covalent bonding is different than ionic bonding because in ionic bonding, atoms lose or gain electrons. So they either, if they have one valence electron or two valence electrons or any small amount of valence electrons, in ionic bonding, they will just get rid of those electrons. Uh, and then a atom with more valence electrons, so 6 or 7, something like that, they will add electrons. Okay, so that's an ionic bond. In a covalent bond, instead of losing or gaining electrons, instead of that, they share electrons. So, for example, as you can see down here, these two electrons here are overlapping between the hydrogen atom and the oxygen atom. Okay, so they are sharing those outer valence electrons for the purpose of getting a full 8 valence shell. Now that's a little bit misleading here because hydrogen doesn't actually have 8 valence electrons, but hydrogen is an exception to the octet rule. We'll talk about that another time. But hydrogen is happy right now with just the 2 valence electrons. Oxygen is happy right now with all 8 valence electrons. Okay, so it is sharing an electron with the hydrogen here. It's sharing another electron with this hydrogen here, so it has a full 8. Same with this over here. Oxygen has 6 valence electrons, so each of these oxygens here are sharing 2 of their valence electrons with a different oxygen. So, for example, this electron here and this electron here belong to this oxygen. This electron here and this electron here belong to this oxygen. They're both sharing those 2 electrons, and so therefore they each have 2 extra electrons, which means they have 8. So, hooray, they have 8 valence electrons. They are happy. They are stable. Okay, so that's the point of, or that's the purpose of covalent bonds, is to share valence electrons. Okay, these type of bonds can happen between 2 different atoms or 2 of the same atoms, like we were just talking about with the oxygen atoms down here. Okay, now when you have 2 of the same atoms bonding together, that is called a diatomic molecule. Okay, we talked about in previous videos, anytime you have 2 atoms bonded together, okay, that is a molecule. Now, most of the time, molecules are made of 2 or more different atoms. But like we just said, sometimes you can have molecules made of 2 of the same atoms, and like we said, those are called diatomic molecules. Okay, it is a molecule because it is made of 2 or more atoms, and it is diatomic because di, the prefix, as you probably know, means 2, and atomic means atom. So di, 2, atomic, atom, 2 atoms. Okay. So generally, covalent bonds form between non-metals. Okay, oxygen, as you probably know, is a non-metal. Hydrogen is also a non-metal. And if you don't remember this, we talked about this in a previous video. Metals are located on the top right corner of the periodic table. Okay, so on the right side of the staircase is where the non-metals are. Okay, so that's the types of things that make covalent bonds. Now, these are the different diatomic molecules. Okay, so as you notice, all of them have a 2 subscript next to their symbol. Okay, so H is hydrogen, N is nitrogen, O is oxygen, F is fluorine, Cl is chlorine, Br is bromine, and I is iodine. So each one of these is considered a molecule because this one is made of 2 hydrogens bonded together. This one's made of 2 nitrogens bonded together, and so on. Okay, these are diatomic. So anytime you have any of these elements, they will never be just by themselves. You will never see just one atom of hydrogen. Okay, you might either have 2 atoms of hydrogen bonded together, or hydrogen will be bonded to some other element. Okay. Okay, now differences between ionic and covalent. Okay, we already touched on this, but ionic bonds transfer electrons. Covalent bonds share electrons. Okay. In an ionic bond, the force that makes the atoms stay together is that the opposite charges attract each other. Okay, you guys probably know that opposites attract, right? Positives attract negatives. So that's how it works with ionic bonds. We have a positive ion, we have a negative ion. They attract each other because they are opposite charges. Okay. Covalent bonds, they share their electrons, and sometimes they share them equally, sometimes they share them a little bit unequally. Okay. Now, in an ionic bond, that bond is between a cation, which is a positive ion, generally is a metal or polyatomic ion. And if you don't remember, polyatomic ions are ions that have more than one atom combined together. Okay, so for example, OH negative is a polyatomic ion. It has O bonded to an H, and it also has a charge. Okay. Anion, which is a negative ion, is generally made of nonmetals or, again, polyatomic ions. Okay. Covalent bonds generally consist of two nonmetals. Okay. So anything that is to the right of the staircase is a nonmetal, plus hydrogen is also a nonmetal, even though it is on the metal side. That is the one exception to that rule. Okay. So that is how covalent bonds work. That is how covalent and ionic bonds differ from each other.